Hello there, and welcome to this demo of the Forta protocol. My name is Hasib, and I'm one of the core engineers on Forta. Forta is a permissionless runtime security network designed to provide threat detection for the decentralized economy. Let's take a look at a real-world example to see how Forta could have helped detect and mitigate it. Compound is a DeFi protocol that enables users to earn interest by lending assets to it, such as DAI, ETH, or Tether. The protocol consists of several smart contracts, one of which is the comptroller that is responsible for distributing earned interest to users in the form of comp tokens. In September of 2021, a change was made to the logic of the comptroller, which introduced a bug that ended up distributing far more tokens to users than it should have. Over $100 million worth of tokens were incorrectly distributed, some of which have been returned by the recipients. This bug could not be quickly patched since the compound governance process requires at least 7 days for any code change to take effect, and there is no pause functionality for redeeming earned interest. A few days later, more funds were sent to the comptroller and put at risk by calling the drip function of the reservoir contract, which holds the majority of comp reserved for users. Let's take a closer look at the code in question. The comptroller contract exposes a method called claimComp, which users can call to withdraw their accrued interest. It calculates how many comp tokens the user has accrued from borrowing or supplying assets to Compound, and then transfers that amount of comp to the user. The bug, which is now fixed, was inside the distribute supplier comp and distribute borrower comp functions. Let's take a look at distribute supplier comp, for example. The if condition on this line should have been checking for a supply index greater than or equal to comp initial index to trigger the if block. Since the if block did not get triggered, it resulted in a much higher distribution of comp. To catch such anomalies in real time, we could write a Forta agent, which is a script that monitors blockchain activity to detect certain scenarios. Let's see how we could use the JavaScript SDK to build an agent and test it on the exploit transactions. One way we could detect this is to listen for distribution events emitted from the comptroller and verify that the amount distributed is what we expected. On every mine transaction, the handle transaction function of the agent is called. In this function, we first check if there are any distributed supplier comp or distributed borrower comp events. If so, we determine the distribution amount using the ERC20 transfer event of the comp token. Then, we query the accrued balance of the user in the previous block to compare the amounts. If the ratio of accrued to distributed tokens is more than double, we flag this using a finding, which would be published to the Forta protocol where interested parties could react to it, for example, by quickly proposing a code change to reduce the amount of time that funds are at risk. Another condition we could monitor for is the invocation of the drip function of the reservoir contract. In this agent, we check for transactions that are calling the drip function and flag them with a finding that includes the amount of tokens that were dripped. Now let's run these agents over some of the exploit transactions to see the findings they generate. In this transaction, $28 million worth of comp tokens were distributed, and we can see that it is correctly flagged by the agent. In another transaction, we can see that the calls to the drip function will be correctly flagged as well. As we demonstrated here, using Forta agents, anomalies in any protocol can be detected as soon as they occur and allow for quick response times before users are aware of any issues. To learn more about how you can start building your own agents, check out our agent SDK documentation at docs.forta.network. You can run these example agents yourself by pulling them from our examples repo, which is also linked in the docs. Thanks for watching.